applause here for Michael, and you'll learn about going around with a language.
Okay, thank you very much, Paul. I think I have the bad job to tell you something about the thing you don't really want to hear anything about, because I think you don't want to hear about a language, but you just want to use it. And in fact, every one of you is using a language. At least you're using a language right now, because you are understanding English while I'm talking. And I think you probably don't know when you first learned English. And perhaps it will be the same with SEMAT, so you will probably in some years not remember my talk here, but perhaps you will probably talking SEMAT. So using the language we are trying to develop on conveying these things Ian just explained, Eva explained, that we are using here. So I want to talk about, well, using languages, the elements of the language we are using to talk about the concepts of SEMAT, and some statement on views on the language, which is some special concept. So as I already said, everyone is using languages to talk about things, to hear about things, to read and write about things. You can make funny puns with languages. So languages are everywhere. And if you're using a natural language, of course, you can explain the world. Of course, that's not what you want to do with SEMAT. We don't want to explain the world. We are just in software engineering. So the language we need is a little bit smaller. And we have seen some diagrams Ian Eva was using. So, well, there are some constructs we need to explain what we want to explain and not more. But we want to have a still flexible language. So we don't want to have a language where it's quite complicated to communicate with. So if you compare to natural language, you have nouns and verbs and adjectives. Well, that's the core elements of natural language. But you can use them in a quite flexible way and explain the world, just with these key elements. And something similar we wanted to achieve with the SEMAT language. And especially we wanted to achieve something that we have a language that fits to anything done by developers. Because we wanted a language to describe what developers do. And this way practices get comparable. Ian was talking about practices here. And that we want to compare them, and if one practice is described in one language and one practice is described in another language, you can't compare them. And if you can't compare them, you can't find out whether this practice is better than yours, and then you won't use it. Also, it might be better. And if the language isn't easy to use, you won't use this language. You will explain your practice in English. So you can't share your practice with a Chinese guy who's not talking English. And the other way around. So we need something that is simple and where you can describe almost everything you're doing as a developer. And as I said, in natural language there are just some key elements, and this is the same with SEMAT. We have 5 key elements of the language, and the good thing is you all know them because they all were in Ian's talk. And you don't know, must need no more. You don't need no more. So there are alphas, work products, activity spaces, activities, and competencies. And they talk about 3 key things, and you have seen these key 3 things already in Ian's talk. So you're talking about what exists in my project, what are the things I develop, what happens, what I am doing in my project, in my method, in my practice, and who's able to do, who can do this, what does it take to do this? And, well, that's basically the things I want to talk about. If I want to talk to someone else, what's my practice? How do I run my project? How do I run my endeavor? I want to tell these things. And so we have a language for it. Talking about what is. What does it take to talk what exists in my project? Well, there are the alphas, the universal things we monitor and control, as Ian said. There's a universal set of these things in the kernel. So the kernel gives us some alphas. And each one has some states. We have seen the sliders on Ian's slide. So each alpha, we can progress through some states. And, well, you might find out a software system Well, software system was one of the alphas. Yes, there's always a software system if I develop software, of course. But a software system is a very, very, very general term. Well, okay. Let's have some sub-alphas, some parts. What are parts of a software system? Well, there's an architecture in a software system. Well, there are some components in my software system. So we can use sub-alphas. They're alphas. They have states. Well, my architecture has some states. My components have some states. Some are implemented, some are not. So it's basically the same concept, but we just layer it. And on the other hand, we don't have only abstract things. We have the concrete things. The individual things we really develop. We call them work products. So you have some piece of code, this is a work product, or some plan, some design model, this is a work product. You produce it, you can take it physically in your hand. And it's up to you to define what are your work products. They are not in the kernel, they are not universal. You define it, you say, okay, I'm using this kind of model, I'm using this kind of code. Well, that's up to you. And you can talk about it. And it also has states, of course. Yes? This is an overview model, or this is a detailed model. So it's evolving through these states. And the one minimal way to define a practice, to tell others what you are doing in your endeavor, well, it's just to relate these work products to these alphas. You have seen there was an alpha named requirements. Okay, what is your work product you're using for doing the requirements? Well, that's your way of working. That's your practice. That's your method. And everything else can be left tacit. It's not always necessary to tell someone, well, I'm talking to the customer, and then I'm doing this, and then I'm doing that. No, you just want to say, I'm using this kind of models or this kind of other work products. And even without saying what you are exactly doing, you have the progress because you have the states. Your alphas are progressing to the states. So you have the evolution of these elements in there without explicitly talking about it. So SEMAT doesn't force you to explicitly talk about it. But of course you might want to talk about it. And you can do. So you want to talk about what happens in your endeavor. Well, quite the same thing. Activity spaces, you have seen that on Ian's slide. The universal things we do. We specify the system, we implement it, we test it. We drive our team and so on. Okay, they are in the kernel. They are universal. And then there are the individual things we do. We write code, or we generate code. We do unit tests, or code inspection, or whatever. These are the individual things we do. We call them activities. And again, it's up to you to define what are the things I'm doing. They are not universal. And both the activity spaces and the activities have something we call completion criteria. And it's in terms of states. And then there's one important thing. We have discussed it quite a bit. How should we do it? And one way would be to say, okay, I have an activity, and I tell you, do this activity, and then you are in that state. Well, is that true? Does it work this way? Well, in fact, it's the other way around. You want to achieve some state, and I give you the advice, do this activity. And it's up to you to decide, I have to stop this activity because I have reached this state. I have achieved what I wanted to achieve. And perhaps I give you the advice, do this activity. And you say, no, I have a better way of doing it. But nevertheless, you're trying to achieve this state. So it's not do this activity and then you're in that state, but the other way around. If you are in that state, you don't care about this activity, you can skip it, or you can stop it. And when I said one minimal practice is to have alphas in work products, and everything else is tested, you can do it the other way around. One minimal practice would be to have alphas in activities or activity spaces. So you're not talking about use this kind of model. No, you're just saying, well, model the system. You tell me what to do in terms of this objective, achieving the state, and don't tell me which document I have to use. So in this case, the work products are tested. And that's no problem with the language. So you can just talk about the things that are really essential for you in your practice. When you're talking about your practice, you just use the elements you really need to use to tell somebody what to do. And of course, you want to tell somebody not only what to do or which document to use, you want to make sure that this person can do it, or you want to find out what must this person be able to do. And you can add competencies. Again, competencies are something that is quite universal. And so they are in the kernel. And each competency has some competency levels, which is a little bit more than just skills. And you can assign required competencies, for example, to activities. And then you can compare your practices. As we just said, you use your language to compare things. And if you have used the competencies, you can say, oh, this practice is much more complicated to use because I need much more and higher competencies than on the other practice. Or the other way around. You have a practice because your company says, okay, you have to use this method for some standardization reasons or whatever. And then you have to form the team.